Hello, my name is Dhruv Bhatt, and I will be presenting the Linux operating system. To begin, I'll give a brief roadmap of the table of contents. There's the introduction, a history, the design goals, the different types of management, user interface, companies currently involved with Linux, and lastly, the conclusion. So moving on to the introduction, before we talk about Linux operating systems, we need to talk about operating systems as a whole. So what exactly is an operating system? Well, the operating system is what manages the CPU, memory, and other tasks. It is built-in software that allows for control of hardware and software resources, and you can think of it much like the mind. If the CPU is the brain, then the OS is the mind. Again, it's a software. When we're talking about Linux, we're talking about specifically a family of open source Unix-like operating systems, because after all, Linux is a Unix clone. And when we're talking about Linux, we're specifically talking about the Linux kernel. And when we're talking about Linux, we're specifically talking about the Linux kernel, and we're talking about Linux distributions, which basically is a package of the Linux kernel alongside other components, other compilers, other shell, other components. So that's what we mean when we talk about Linux distributions. There's a whole host of Linux distributions that I'll talk about later. So moving on to the history of Linux, it was founded by Linus Torvalds, and he's the one that actually developed the Linux kernel. He was a student at the time at the University of Helsinki in Finland, and in fact his master's thesis was over Linux. And at the same time as he was working on that, the Free Software Foundation was working on the GNU project, and they had built these other components, but they hadn't quite mastered the OS kernel. They had other independent GNU components built, components for multitasking, networking, virtual memory allocation. They had these different components, but they didn't have the kernel, and that's where Linus Torvalds bridged the gap by combining the Linux kernel with these GNU components. And this is what fueled the growth of this open source adaptations. So moving on to the design goals of Linux, as I stated previously, it is a Unix clone, so the architecture is also similar to Unix. And you can see that in some of the models here, the way the hardware interacts with the kernel and so on and so forth. Well, let me explain. There's the kernel module, the standard library, and the system utility. The kernel module obviously being the most important, because this is what interfaces with the different hardware to allocate memory for individual tasks and processes. The standard library is referring to a set of functions for how programs interact with the kernel. And now finally, the system utility is for special management tasks. An example is shell script, which is a way that the user can directly talk to the operating system with specific commands and codes. Moving on to memory management, what we're really talking about is physical memory versus virtual memory. Physical memory being the actual physical memory address space on the computer, and virtual memory being the way that it's mapped, that the memory addresses are mapped to the physical addresses. And so, as you can see here, there's a virtual machine subsystem within Linux, and this includes important allocators for paging. For pages, the slab allocator, the buddy allocator, and the zone allocator. And this is how pages are allocated and deallocated in memory. And when a process with the virtual page number is invalid or doesn't exist, that's when a page fault occurs. So the kernel must step in, and it has to resolve the issue by swapping processes between memory and the disk. So in virtual memory, we have what is called demand paging, and this is when a page. This is basically where the pages are loaded from the disk to memory only when the page is required, meaning it is not preloaded, and so it mitigates it mitigates the time it takes for this process to occur. Moving on to processor management, we're talking about two different types of processes, and those are interactive versus non-interactive. Interactive being the ones that run in the foreground, and non-interactive being the ones that run in the background. And the main type of processes that we have is the parent process, child process, orphan process, zombie process, and daemon process. And when it comes to process scheduling, the primary and most recent algorithm used in Linux OS is the CFS, which stands for Completely Fair Scheduling. This is a complex approach that combines preemptive priority scheduling combined with time slice quantum scheduling. So it's the best of both worlds. Moving on to device management, the most important thing to note is that in Linux operating systems, the devices are seen as files. Whether that be the network interface card or a printer or the input-output, it is all seen by the operating system in a file structure. And so these device drivers access disk storage through two different caches, the page cache and the buffer cache, the latter of which is required for any valid data that is in the buffer cache related to the device, where the system doesn't need to access the physical device. So there's three different types of devices: the character device, the block device, and the network device. So a character device is one in which there is no buffering performed, and the response and process time is higher, but the driver can only communicate by sending and receiving a single string of characters sequentially. Block devices, on the other hand, are ones that are accessed through a buffered cache, and it can be accessed in any order. It doesn't just have to be sequentially. A network device refers to that which is responsible for communicating with the kernel regarding the packets of data that are sent over a network. And so the transmission and receiving of these packets is done through this network device. Moving on to file management, we're talking about a file subsystem versus a directory, which in Windows nomenclature is a folder. And so we have different types of files. We have normal or ordinary files, special files, and, as I stated, directories. So an ordinary file is exactly what you think it is. It's any type of common file, like a readable or an executable or a compressed or an image file, any type of basic file that exists in this tree-like structure. Now, a special file is a type of file that performs specific functions. For example, I mentioned how devices are seen as files. So a block and character device file, as I mentioned in the previous slide, those are examples of special files. And of course, directories of which are known as a folder, and that's what forms the very basis, again, of this tree-like structure. And you have the virtual file system here, which is depicted, which shows the way that Linux views any type of file system, in that you have different file system types: superblocks, inodes, D entries, and files. And this is the overall structure of it. And having it like this, one of the main advantages is that the user isn't burdened with the specific implementation of a file system. All that they are worried about, all the user is worried about, all the user is bothered with is reading and writing to a file. That's it. And that's a huge upside of Linux. Moving on to security management, another huge upside of Linux is the way that files are accessed and permissions are accessed. As you can see from this image, you have security access based on 3 bits. 3 different bits for the user or the owner, the group, and the other, which is other users that are not in the first 2 security access groups. Specifically, these permissions given are read, write, and execute. Read, write, execute. And so they're given specifically in this order. It will always be in this order. It will always be read, write, execute. That is the standardization of Linux. And this is copied over from Unix. And this can also be represented in an octal notation. So this is the character notation. As you can see, this is dashed, read, write, execute, read, write, execute, read, write, execute. So if this were represented in octal, well, read is represented with 4, W is represented with 2, and X is represented with 1. Therefore, this in octal notation would be represented as 0777. Again, this is a huge plus for Linux. This is one of the reasons Linux is so secure. Moving on to the user interfaces, there are 2 types, which is the graphical user interface and the command line interface. As you can see, the graphical user interface allows for clicking of buttons, resizing of windows, and such, although it is more cumbersome as far as system resources are concerned. So that's why the command line interface is often preferred by programmers and on servers and such, is because it is not as resource intensive. But at the same time, the command line interface, you have to input direct commands because you're talking directly to the operating system through this interpreter, which is translating these instructions to the operating system. So moving on to companies that are currently involved with the Linux operating system, first and foremost we have Google. Google has the Chrome OS, which is the proprietary Google operating system, which is actually a Linux-based operating system, and they run that in all of their Chromebooks, which is their laptops. And because their laptops are so inexpensive and they're so reliable, institutions of education have taken note, and they want this for their students. And with the onset of the pandemic, and with more with more institutions of education going towards remote learning, it has only skyrocketed the popularity of Chromebooks, of Chrome OS. And of course, Android OS, Android operating system for smartphones, is also trademarked and owned by Google. So what this means is that most people have interacted with a Linux-based operating system at some point. I mean, the market share for Android worldwide is 70%. So this just goes to show how far Linux has actually come since the 90s. Another huge company is Oracle. They're a well-known tech giant, creator of Java. They have database solutions, they have cloud computing solutions, and they even have their own distribution of Linux called Oracle Linux, and they have this enterprise-wide. So that means all the computers at Oracle are running Oracle Linux. So in conclusion, as I stated before, now more than ever, people are being exposed to Linux OS based systems. whether that be through embedded systems, whether that be through Google, as I said earlier. The adoption of it has come a long way since the 90s, and one of the main reasons is because it is open source, is because it can be freely and commercially distributed, and because it can be modified however you want. And so that is the driving force behind the growth over the last 20, 30 years. And seeing that, we can only postulate that in the future it will only increase. This is a linear function, if you will, that as time goes on, Linux-based operating systems increase. Of course, there will be some point where they overtake Windows or they become the main, but as far as the immediate future goes, we can expect a continual increase of Linux-based operating systems. Thank you.